Welcome back to the another session of our data structure journey. Last video we are completed how to delete an element from the first position of the linked list. Right now we are going to delete the element from the last position of the linked list. So here also there are multiple cases we have to consider. That is, the first case is list is empty. If list is empty means there is no element present inside the linked list, so we don't have to delete any. So we have to just print the message and we have to exit. Second case, list have the single element. If the list has single element, then the single element we have to remove and make the start as well as the last pointer as the null. After that, what happened? List is empty. In our implementation, we are using two pointer, first pointer as well as the last pointer. First pointer is used to address the first node, that is the start. Last pointer used to store the address of last node. Then last case, that is, list have more than one elements. So if there is more than one element, then what happened? We have to remove the last element and make the last node as the previous of it. Means the previous node of the last node we have to make as the last pointer. Actually, what happened? Maximum program, the linked list implementation, they all use the only one pointer. Maximum use the one pointer, that is the start pointer, to store the starting address. I prefer to use a pointer to store the last address. So whenever we are removing the last node, unnecessary, we don't have to traverse from first node to the last node. This is the only advantage of using a pointer that points to the last node. So case one, so we are already, if there is no empty, we have to just print that there is no data. Case two, list have single element. Then for example, this is the single element, one element is present, that is 45 is present. Start points to this address and last also point to this address. So here what happened? Make the start pointer as a temp pointer, print the data, then make the start as well as the last pointer as a null, and we have to free. So here same thing, we have to make the last as well as the null, then we have to free it. After that we have to free it, and before that we have to just make a pointer temp and we have to print this. So this is the case we have to do. Third case, that is, if the list have more than one element, then what happened? We have to make the last node as a last of previous node and we have to release the last. So here these are the steps. So for example, this is the linked list is present. There are three element is present, 10, 20, 30. Start pointer points to the first node with the address 100. Last pointer points to the address of 300. Now, what is our objective? Our objective to delete the last node means this node we want to delete. So, make the last as temp pointer. Now, we have to make the temp as a last pointer that points to the last. So, at this moment, what happened? Temp as well as last, both the pointer points to this node. Both the pointer store the value of 300. Print the data to be deleted. So, we have to print what is the value, that the 30. Make the previous node of the last. So this is the, which one is the previous? This is the previous node. So now we have to make the last node. Right now last node point to this one. So we have to make this last node point to this one. So now last node point to this one. Then make the next pointer of the last node, because this node is becomes to right now become last node. So last node next always points to the now right now it store points to which node? This node. So this value store the 300. Right now we have to store the null. So this node does not point to any node. Then we have to release the memory. So after that, what happened? We have to release the memory. So we release the memory. So this is the way we have to delete an element from the last node. So this is the possible cases. There are three cases. According to that, we have to write down the algorithm. Then we have to convert into the implementation, and we are implemented in the C language. I have already implemented in the C language for the insertion all the element, first position, last position, in between, delete first. Only we have to write down the delete. It is a menu drive program. I have already done in the programming, and this is the sequence of the previous video. So if you have any issue, you can go back to the previous video. According to that, the sequence we follow for the menu drive program, and one by one, we are just adding the function and execute the program. So this is our menu type program. We have started from the video when we start the double linked list. First part, one by one part we are covering and we are adding the function. So this is the structure declaration. Node has three elements: info, next, back. We initialization last as well as the start as and all. So this is first video we completed, insert into the first position or begin position, then display. Second video we completed, that is insert at last, then insert in any position. Then we completed the another video, that is the delete at the last position. Last position. We are already completed the delete in the first position. Right now we have to go for the delete in the last position. So the function does not return value. So void delete last. Actually, I make all the function does not take any parameter, does not return. Reason is that it is easy to implement because we are in initial stage of data structure. If we go for complicated program, then it will very difficult. That's why I make all the function as a void, means does not return any value, does not take any parameter, and all the things start and last I make as a global, so any function can able to access. So here what happened? So this is our algorithm we have to follow. So first one is list is empty, then we have to print delete not possible and exit. So this case first we have to ask, so if list is empty, how to know? If start equal to null means list is empty. So we have to write down printf list is empty. So we have to write down list is empty. Else if. So what is the second condition? Case 2, that is list have single element. Now, how to know list have the single element? Means if start next is null, means there is no element, only one element, that is the start is present. So start next equal to null. It means that the list has only single element. So here we can write down list is empty. Here this is for the list. Oops, single. Now here what happened if so make the start as a temp pointer. So here we have to store the value of start inside the temp. So what is a temp? We are not declare what is a temp. So we have to declare that is temp is a pointer that store the value of no type data. So now this is start, we store the value. Next line is print the data to be deleted. So here it is mentioned print the data to be deleted. So we have to write down printf new line %d deleted. So we have to write down this value is deleted. Then which value? Where it stored? It stored the info part. So 10 info. Then make the start as well as the last as a null. So we have to make the start as well as the last as a null because there is no element after deletion as it was a single element. Then we have to free the memory or release the memory. So free the temp. So this is the case when list have single element. Case 3, list have more than one element. So this is the else part. List have more than one element. So in this case, what are the things we have to do? First, make the last as a temp pointer because we have to delete from the last. So we make the temp equal to last. Then print the data to be deleted. So we have to write down printf %d deleted. Which value? Temp info. Temp info. Then third one is make the previous node of last as a last node. So previous means where it store? It store the last back. So we make the last equal to last back. So last back store which value? Previous node address. So it is easy to. That is the reason I use the last pointer to store the address of last node. Unnecessary, we don't have to traverse to reach the previous node of the last node. This is the advantage. Then feed the, then make the next pointer of the last because it is a last pointer. So we make the last next equal to null, equal to null. Then free temp. Now we have to release the memory because we are all make all the connection. So we have to release the memory. So this is the way we have converted our algorithm into the program code. Now we have to add the things inside the menu drive program. This is our function name. So we have to add inside the switch case, that is here. This is case 5, this is case 6, this is case 7. Then here it is 7. Then printf statement also we have to add this one. Now 5 is delete at end position. After that, new line will be created. After that, 6 conditions. New line, then 6 is the display, 7 is the exit. Okay. Let us compile the program. Then we have to run the program. Right now, before going for deletion, first we have to insert the data. For example, 10, then 20, then 30, then 40, then 50. So each and every time we got the message insertion completed. Let's display. Display is right now 6. 10, 20, so 10, 20, 30, 40, 50, yes. All the element is inserted in the, because we are already used the second option, that's why I insert at the end position. Now, we have to delete. If I go for delete, which element will be deleted? 50. So let's enter 5. 50 deleted. Yes, we got the correct answer. Now, again, we have to go for, that is 40 deleted. Yes. Then 30 deleted. Then 20. Then 10. Then list is empty because we are already deleted all the elements. That's why we got the value. That is the deleted is the empty. For example, I go for 6. List is empty. We got the same answer that the list is empty. We have to just know how the actually it's perform its operation. So this is our function, does not take any parameter, does not return. So here what happened, we make the temp as a pointer that store the address of any node. So this is the case for the case 1, that is the list is empty. So if there is no element that the start equal to none, then we have to print the list is empty. Second case, that is list have single element. Let's take an example. This is a single element present. Let 10 is present. This is the start because only single element. This is the last. So both the nodes. So here what happened? Temp store the value of this one. So here what is the operation it is going to perform? So now temp point to this node. Then we have to print the percentage deleted. So what is the percentage? Temp info. What is temp info? So it will display 10 is deleted. Then start equal to last equal to null. So now what happens? Start store value of null. So if store the value of null means it does not point to this node. Then last store which value? Null. So if the last also store the null value, then what happened? The connection gone. Then free temp means we are release the memory. So after that, what happened? If you release the memory means the data connection is gone and the memory is already gone. So it will display the 10 elements. So this is the case to delete one element whenever there is a single element is present. Then third case, list have more than one element. So for example, this is a list of elements. So this is point at the first node, this point to the last. Actually, my main purpose to take two pointer only for that whenever we have to perform any operation in the last node, no need to traverse to reach the last node. So here what happened? List have more than one element. Now more than one element is present. Yes. So what happened? Temp store the value of last. So here what happened? We make a temp that store this value. Then print a percentage deleted which value? Temp info. What is temp? This one. So for example, this is the 5. So it will print that is the 5 deleted. Then last equal to last back. What is last? This one. What is this? For example, this is 100, this is 200, this is 300, this is 400. So this is not store which value? 400 value. This store which value? 300 value. Now last store which value? Last back. What is last? This one. What is last back? 300. So now previously what is the last address? 400. Now which value is stored? Last means 400 back 300. Now it store which value? 300. If you store the 300 value means it points to which node? Now it points to this node. So this connection is gone. After that, last next equal to last. Right now, what happened? This right now, this is the last. Last next which address? 400 means it point to this one. Whenever we make this node as a last node means this should be points to which value? Null value. So right now 400 gone. Which value is store? Null. It points to the null. After that, what we have to do? We have to make the free the temp. So now we have to remove the temp. This temp data is already gone. So after that, what happened? The last element of the linked list is gone. So this is the way we are deleting the element from the last position. Thanks for watching the video. Please subscribe the channel as well as like and share more. Thank you for watching the video.